here it is, the final CCNA1. It's a network, and I have to apologize already. It has a lot of great stuff in it, but a lot of these commands you won't see again until like CCNA3. So this is a really hard test. So let's get into that. Devices and small networks. Alright, so once we load here, a typical small network, we have one router connected to one switch, and it might not be a router, it's probably a modem in most cases, like DSL cable modem, and then just connected to the switch, and hopefully if the business is doing very much, we have some kind of firewall appliance so that we don't get CryptoLocker or some kind of virus, but this is what we typically see in a small network, right? Pretty simple. You probably don't need to be a real great network administrator to keep this running, as it's one network. What factors do we think about when we do these? Well, I hate to tell them this is not just for a small network. We think about cost, the amount of ports, the speed of it. Is it expandable and manageable? Okay, and a lot of people don't buy manageable devices in that small of a network. So what this means, ports, how many we have, what kind of speeds is our device supporting, right? Still not that important, but expandable, this means as the business grows, can we grow with it? We want to keep ourselves from being a flat network and be a scalable and dynamic network, right? Manageable just means we can use all these commands that we've been learning, rather than it's just a dumb device that we just plug in and can't do anything with. We don't want something like that. So then we go here. Alright. Designing IP addresses for a small network. Same as designing, we break it in and we put them in the same network, or we don't, right? Okay. So we need a manageable device for this kind of thing. Redundancy in a small network. Yeah, we could have this. Actually, redundancy in a small network is easier than a big network. It costs a lot less. So we just want to make sure our servers go to multiple switches so that if one goes down, it doesn't crash the whole network. Alright. Other things to think about. Well, this would be called QoS, quality of service. And so we can prioritize traffic. And voice, and we have the highest. Also, video would be up here in this high priority. The rest of it doesn't really matter. And then like FTP can have low because, the data is going to get there. Anyways, QoS, they'll talk about this again in CCNA5, but yeah, this is not. This is a little bit beyond what I consider CCNA1, but go ahead and read through it. It's just it's good to know voice takes more and video would take more as well. Then the rest could be normal. We don't want it to be too slow, especially like IMing or our mail transfer. We want our mails to get sent sometime, but it doesn't have to be immediately. On our voice, if it doesn't get sent immediately, we have it cut. It's like, that kind of sound going on. Just voice dropping, packets dropping. So it needs a high priority. Alright. Identifying network planning and design factors. How many users we have, what types of yeah, alright. So go ahead, try this out. Anyways. Common applications in a small network. Well, same as a big network, except a few less, right? We have, I don't know, Word documents, and I don't know, this is just a stupid section. So we have mail, that kind of thing. Here we go. DNS, Telnet, hopefully not. Hopefully it's SSH. Remember, Telnet is a horrible way to manage a device. IMAP, SMP, POP, email, DHCP, right? This gives us these are all of our email services. DHCP gives us our IP addresses, web traffic, file traffic. Anyways. Real-time applications, VoIP, which is the same thing as IP telephony. in real-time applications such as, this would be video. Right now, these phones with video and voice and everything, they've come down in price, so it's very common for businesses to be running on VoIP phones, even if they don't look like this. A lot of traditional, might have a digital line, but the endpoint, because of the cost, is so cheaper with VoIP. The end gateway is actually a VoIP gateway. So, but once again, I think that's beyond where we are in CCNA, but hey, Cisco wanted to let you know about it. Make sure you look at these applications because they are important. Scaling a small network. Alright, this is the most important thing, no matter what network, what size you're doing. Network documentation, when I talk to employers, they always say, these guys need to document better. So, what we usually do is have drawings in what's called Visio, or whatever is the best. There's a lot of network documentation tools to do them by yourself, but when you're a small network, you're probably going to be doing it by hand. Device inventory, I don't think that's much different than in my documentation. It's the same as device inventory, but of course we want to keep a spreadsheet of everything we have, so when it gets stolen we know, right? Or we know how many devices we need to upgrade when they go end of life. Budget, oh, okay, well, in case you guys didn't know, devices cost money, so we need to know our budget. Traffic analysis, alright, this, another important thing. This is what's going to help us decide what devices we need for the future, for applications or whatnot. Traffic analysis, how much bandwidth are we using, do we need faster forwarding rates, blah blah blah. Okay, we'll be talking about that in other CCNAs as well. Alright, so traffic analysis, what they're talking about is setting what's called a baseline, so we know what our network does, or actually, oh, this is traffic flow. Okay, so capture traffic in a traffic flow during peak utilization to get a good representation of the different traffic types. Perform the capture on different network segments because some traffic will be local to a particular segment. Alright, so that's that. I don't know. It's just talking about, okay, so learn to use your task manager, apparently. Well, I don't know. Like, basically what I think they're saying here is as IT evolves, we need to know OS versions, how much network our applications are using, especially when we start going to big networks. Our server CPU utilization, drive utilization, RAM, and I guess this could be computer too, because whatever we're running, we want to make sure when we design, if you're buying a computer, you want to make sure it actually is going to run for your network, not that it's just cheap, right? So if you don't know how much the stuff's using, it's real hard to figure out what you're going to buy. Alright. Categories of threats. Information theft. That's people stealing money. Data loss and manipulation. I think that pretty much explains itself. Identity theft. Hopefully you know that. And then finally there's denial of service. Okay, so these are some security risks. Physical security. Keep hardware from being damaged. Environmental threats are temperatures. We don't want our AC to go out and our devices to blow up from being too hot, or getting humidity and being too wet or too dry or too cold. Electrical threats, we don't want our power could go out and that would be bad, or we can have power spikes and destroy our thousands of dollars of devices, and that wouldn't be good either. Maintenance, poor handling of key, electrical components, I don't know. You can read through there. On physical security, most of it just makes sense. Types of security vulnerabilities. Basically, this means update. Basically, the solution to this is update and don't use end-of-life stuff. You're always going to have vulnerabilities. The more applications you use, the more features you have on your devices, the more chances for vulnerabilities. So we have, there are 3 primary vulnerabilities or weaknesses. Technological, So that would be the services we're running, right? Then we have configuration. We didn't secure the device, we didn't configure it right, we left some holes open. And then finally we have our security policy. You know, we have to tell people, hey, you can't hack stuff, you can't look at inappropriate stuff at work and download strange files. You know, that's what our security policy should. It should have best practices and what we can do with the technology at work, so that when people keep getting viruses, they can't say, oh, I didn't know I couldn't download illegal files at work. So what does a virus do? It depends on the different viruses, but so a virus is basically a computer program, right? You can do a lot of things. Then we have a worm, which is going to attack the network. A Trojan horse, it looks like a real program, but it is letting people in through a back door or some other kind of thing. The first step in hacking is doing recon, and here's types of reconnaissance attacks. Mapping our networks, looking for vulnerabilities. Then stuff we don't have locked down would be an access attack. Denial of service means they're going to crash ports that we have open. I wouldn't call that a recon attack though. But anyways, access attacks. They exploit known vulnerabilities. Denial of service attacks. They'll crash your server and make it so your server can't handle packages coming in, so that someone can't get your website or anything like that. If you're e-commerce business, real bad deal. So types of DOS, we could overload we could overload disk space, bandwidths, or buffers. We could ping flood, packet storm. What else? SYN flooding, Smurf attacks. Anyways, you can look at those. So, keeping your network safe, backup, upgrade, update. I'm sure Teresa has talked about this, but this will be a test question for a worm attack. You want to contain it, you want to inoculate it, you want to quarantine it, and then you want to treat it. Alright, so containing means contain the spread of the worm. So take the first device off the network, hopefully, and then start patching all systems where the vulnerability allowed the worm in. Quarantine, track down each infected machine inside the network, disconnect, remove, or block the infected machines from the network. Then treatment, clean and patch every infected machine. Some worms may require complete core system reinstalls to clean the system. Alright. AAA, when you go into security, you will learn all about this, but AAA is authentication, authorization, and accounting. So authentication is proving who you are, right? We can look at this as a credit card. Who you are, I'm this person with this credit card. Authorization, do I have any money? Accounting, what did I spend my money on? Okay, that's the AAA in a very simple nutshell. You can read on to that. Firewalls, there's several types of firewalls. There's packet filtering, prevent or allow access based on IP or MAC address. We can filter on a firewall that way. We can application filter. We can say this is an approved application, this isn't. We can URL filter, blocking URLs. We can do stateful packet inspection. Incoming packets must be legitimate responses to requests from internal hosts. Unsolicited packets are blocked. So there's appliance-based firewalls, such as this. And Cisco's not the only one to make them. Hate to tell them that. There's server-based firewalls, where it's all the traffic. A server-based firewall consists of application runs on a network operating system, such as Unix or Windows, and usually it's scanning. We send it through there. Integrated firewalls, they're built into these little things, and they're trying to be these, but these appliances, we use them because they're going to be faster. They have their own CPU. They can do more advanced features. What they're not telling you in this is there's stuff called intrusion detection systems and intrusion prevention. Intrusion prevention starts looking for strange traffic and blocks it. Then there's personal firewalls, which is just like a software firewall, such as Windows Firewall, or we could do a third party. Endpoint security. Put malware, antiviruses, and firewalls on endpoint securities. Just because you have a appliance firewall doesn't mean you need to take your firewall off of your endpoints. And so, yeah, I'm talking to you guys that are in class. When you're having troubles, just turn off the firewall. That is not a realistic approach. You should learn how to make firewall rules. Alright. Securing devices. We want to put passwords on them. We want to restrict everything we possibly can and turn off unused services. Passwords. I'm sure you guys have talked about this, but hey, don't make a crappy password. Passphrases are the best. Additional password security, we can run this code. Service password encryption from global config. As you can see, what that's going to do is it takes this line VTY password. In the past, you would see it in clear text. Now you can't. You will have to do some of these in the pack tracer, so make a note of these. Login block for 120 attempts within 60. Okay, so what this is actually saying is block the login for 120 seconds if you get 3 login attempts within 60 seconds. So if somebody's trying to brute force into your device, it's going to stop them from doing it. Security password minimum length, that's going to make your minimum length for a router, for this router, its password will have to be over 8 characters. So all these commands right here, you will have to do in this final packet tracer, so I would take a note of them. Exec timeout, what this means is when you're in the line VTY or the telnet session, it will time you out after 10 seconds. Alright, enable SSH, finally. Telnet sucks, right? It lets us remote in, but it's in clear text. So, we set up SSH, and how we set up SSH is we have to assign first a domain name. That's what they are doing right here. IP domain name from global config, and then any name. This could be don.com. It would usually be where you work. So, whatever their domain was, you do that. Then we type crypto key generate RSA. I don't do general key. It's crypto key generate RSA, enter, typically. General keys modulus 1024. Yeah, it'll do all of this. You don't have to type that. You just have to do crypto key generate RSA. And you'll also have to do this in this final pack tracer, so make sure you do it. Okay, difference between SSH and telnet, besides that it encrypts, is that it has to have telnet. You can sign in without a user. SSH you can't, and so we're gonna do a command username Bob secret. This could be password, but secret just makes it an encrypted password, and so this is then the password for this user. Okay, then we go into login line VTY, and we can change it to only accept SSH. We also do this login local. We've done login in the past for telnet, but login local will allow it to use this username. Okay, so make sure you take down all of this as well, because you will have to do this in this final packet tracer. The keys are also right here. The key length, when it asks you, you want to do 1024 or something above 700, because you could also do, there's a command IP SSH version 2, and version 2 has to be, I believe, above a 700 key. Anyways, so you'll probably be asked to do that in your next one. So then testing services. This is called ICMP. We have the ping command. You guys have been using ping. I've seen you do it. So ping is just testing connectivity. It is not cached. It is instant. From an iOS device, an exclamation part means the ping was there. Alright? The period means it expired. The U is an unreachable message. So what's the difference between the U so this one means couldn't do it. U will actually tell you usually where the device failed. So unreachable means that it didn't know where the network was, but it went along a path for a while. That's my best definition of unreachable. From a command line, I'm sure you guys know, we just do ping. So ping 127.0.0.1. That's the loopback, and so what this is testing is the IP stack. And if we can't ping our loopback, we can't ping anything. Because if we can't ping ourselves, we can't ping anything else. So loopback's the first attempt. Then we ping our actual assigned IP address, and then default gateway would be our best way of trying to figure out some problems. Extended ping is on our iOS's. We can say ping enter, and we can enter in all this stuff, right? So we can choose a protocol. So we can choose IP or IP version 6 or Apple Talk or whatever layer 3 protocol we want to use. The target address, how many times we want to send a ping, the size of the ping, the timeout of the ping, and if we do this extended command, we can then say, hey, source address, and all this. I never knew any of the other stuff, but you could, I guess. I don't know where you'd want to do that, but what this actually tells us is just because this router can ping this PC, we don't know that this PC, and this works better when we have lots of routers, because we're like, is it actually getting there, or is it just going to this interface? We can actually test both of these interfaces. We can send a ping directly from there, rather than we don't know where it's sending it from. So like, we know that these are directly connected, so they should know the route, right? So this guy knows the route to here. But we want to know if this one knows the route to here, okay? Or something like that. So we can actually test sending a source address rather than just sending a ping from, when we have multiple interfaces, we don't know if each one is actually known by this router. Like, if we ping from here to here, it tells us that this router has a route to here. And then if we ping from here and it fails, we know that this router doesn't have a route to here, even though it definitely can ping here because it's directly connected, and it knows this one, so we need to get a route for this network into this router. That's where extended ping works out. So here's network baseline. So network baseline is where we it's going to help us. We want to run the test at different dates, right, and see what's going on, so that we can, a baseline, what it's doing is we're running it when we first set up our network, probably when there's not a lot on, to see if we're going at a different time. It shows us how much latency is put on our network at different times. So the baseline is what we're going to measure performance with. Okay, so that's that. Then traceroute, another ICMP. Hopefully you guys know this. And so what traceroute does is each time a device, each time a packet is de-encapsulated, which is going to be at a router, right? So if we went from here, it would tell us this router de-encapsulated it, then this router, then this router, and then this router. And if we're sending it here, it hits here. But if it doesn't make it there, we're going to see where the last router it was sent from before it failed, which can help us isolate a problem. That's traceroute. So in a Cisco device, the command is traceroute, but in command prompt, it's traceRT. Okay. Anyways, hopefully you guys have used that before, but another valid, very good command. So here's some show commands, and they ask you a bunch of test questions on here, so make sure you go through here. So show run, hopefully you guys have seen this before. It's going to show you your interfaces. It's going to show you everything that you've programmed. It is probably my first go-to troubleshooting command to see if I didn't turn something on, didn't put something in. Alright, so issue the show run. Show interfaces is going to show me a lot of stuff about my interfaces, like am I not getting, are frames not being delivered, am I having frame errors, is my MTU right, what is my bandwidth, what's my IP address. So that's show interfaces. Show ARP shows our ARP table from a Cisco device. It's ARP space dash A, and hopefully you guys remember that ARP is a layer 3 address to a layer 2 address. And show IP routes, going to show all of our routes. This right here is showing that C, remember, means directly connected. R means from RIP. D, if you look up here, is EIGRP. B is BGP. O is OSPF. And those are the ones we really care about. So this is the routing table. Next we have show protocols. This is going to show our routing protocols. This one's probably showing RIP or something. Internet protocol. Routing is enabled. So that just means IP forwarding is enabled. And there's actually no routing protocols running. Alright, but I guess it also shows us if our protocols on our interfaces are up. But this will become a command. Maybe that's show IP protocols. But anyways, it'll show our routing protocols as well in the future. Show version. This shows us everything. There's been test questions on it. It shows us stuff on resetting our router, which we change it between 2102 and 2142 to password reset. It tells us to bypass configuration, change that. It shows us how much NVRAM we have. It shows us our image, where our image is loading from. It shows us how much RAM we're using, what we have for fast Ethernet interfaces, what we have for WAN interfaces. This one has a VPN module. It shows us all kinds of stuff about our system. But the most important is probably how much RAM we're using and how much RAM we have, how much flash we're using, and how much flash we have. Okay, so that's show version. Little video about watching those. Viewing switch settings with the show version command. You can go through there again. I mean, this is just showing you what is in the show version on the different devices. There's packet tracer. I definitely try out this packet tracer and use some of those show commands so you know how to do them, because they never go away. Alright, so IP config /all. Hopefully you guys have seen this before. Shows you all this information: DNS, DHCP, what our IP address is, what our MAC address is, what our IP version 6 address is. Okay, ARP commands, ARP-A. It's going to show us our ARP table, which shows us our layer 3 addresses to layer 2. Hopefully you guys know that. Now there's the show CDP. This is a new one. Show CDP is a Cisco proprietary command, and it stands for Cisco Discovery Protocol. And so show CDP neighbors shows our directly connected Cisco neighbors and what their name is, what we're connected to them to, when's the last time we had a CDP packet sent to them, or hello sent to them, and what platform they're running on, and what we go to on them. And then if we do show CDP neighbor detail, it shows us even more, such as the IP address and then all that other stuff, but just in more detail. Okay, so that's what CDP is. It's a highly valuable layer 2 protocol that it tests layer 2 connectivity. We can always test layer 2 connectivity with CDP between a switch and a router, right? But it's not going to show us our PCs, right? It has to be Cisco devices. So these PCs are not going to show up on CDP neighbors, and it's only your directly attached neighbors. Like this guy and this guy would be seen by R3, but not R1. R1 is not going to be seen by R3. Okay, directly attached neighbors. Anyways, read through there. Issue some show CDP neighbors because it is a great command. Then we have the show IP interface brief. If we want a real, it's basically a summary of our interfaces and what IP addresses we have set to them. Are they up and down? All of that. Take a look at that. Then there's a lab, managing iOS configuration files. Ooh, this one's fun. Okay, so this is our TFTP that you've heard of before. Okay, so how we issue TFTP. Well, we can say show file systems. It's going to show our flash and all that. This colon, or this wildcard right here, what it means is where we booted from. Our default boot is this colon on there. dir is going to show us what's in our flash. We can look at the NVRAM if we want to. I never actually look at this, but this is what's in our NVRAM, and that's our startup config, right? The switch file systems, same deal. So now backing up and restoring. So we can, what we do is we go to somewhere like SolarWinds, and they're using Terraterm, they're doing a different thing, but SolarWinds has what's called, you just have to find TFTP server. Alright, and we're used to saying copy running config startup config. But with TFTP, what we'll do is, oh, they're backing up. But anyway, so through TFTP we can copy the flash, the operating system, to the TFTP server, or we can copy the configuration to the TFTP server. Both, right? We want both of those. Usually we use a secure protocol now with the configuration, because this would allow someone to steal our configuration, which has all of our passwords and everything, and crack them. So we use usually a thing called SCP, which is Secure Copy Protocol, I believe. Anyways, so how we do that is we say copy running TFTP, and as you can see here it says remote host, and what this is asking is, where is your TFTP server? So you send it to your TFTP server, and then the next question is name the configuration file. So it says Tokyo config, so if you press enter it would just be named Tokyo config. They named it Tokyo.2, right? So it wrote it as Tokyo.2, and then you want to see these exclamation points. If you're scared on this, don't worry. On this final packet tracer, you're going to have to do TFTP to a TFTP server, so hopefully you can figure it out. If you want to back up the opposite way, you would say copy TFTP to running config, and it would actually pull this configuration back in. But like I said, you can copy your running configuration or your operating system on there. You can also use a USB. They have your directions down here. This would be an emergency case, in my opinion. So anyways, but take a look at it. It's similar to the TFTP, except we say USB to do that. There's a packet tracer I'm backing up, so if you have questions on that, I'd try out that packet tracer for sure. And now they're talking about ISRs. Great. So your home device, right, it works as a wireless device, as a switch, and as a firewall. And so it's called an integrated services router, right? So you have your Linksys, and so this right here works as a switch, this works as a router, this works as a wireless access point, right? And I'm sure you guys are familiar with this because it's probably how your home device works, but if you're not, you can look at that. Okay, so then there's wireless. When we go to wireless, we have ways of encrypting our traffic, right? So we go on to these SSIDs, and so if they're open, anyone can kind of see what's going on, right? So we configure encryption of our traffic with WEP or WPA, and hopefully not WEP. So if your device uses WEP, it's really bad because this password can be hacked in less than 30 seconds. But anyways, it's your basic wireless equivalency protocol. It was real popular years ago, but then they went to Wi-Fi protected access, WPA. And so WPA uses two types of keys, either TKIP or AES, and so it's more secure and it's dynamic. So if you have the choice, you go with WPA. It's more secure than WEP. All right, and that's that. If you guys don't have experience with a home device, such as when you're looking at this, configuring wireless from a home device, there's a Linksys router packet tracer. You can launch that up and it will show you can set up WEP and all of that, and take a computer, a laptop, and connect to the wireless on packet tracer and see if you know what you're doing. Alright, so here's a I won't even do that capstone, but if you guys want to warm up for the packet tracer that's coming, I would definitely do this packet tracer skills integration. Alright, that was the final chapter. It was kind of a short one. Hope you enjoyed it. I know it was pretty fast, but once again, you're not going to be tested a whole lot on this, besides maybe on the final, this kind of stuff. It asks you some pretty crazy questions. It throws a lot of stuff that we're going to be studying in the future. And so don't kill yourself on this. Probably chapters 9 to 2 are much more important. Learn the theory of those, and these ones will just come in the future. Anyways, hope you enjoyed it. Send me an email if you have any questions.